Borglum looked to the Greeks, who had once copied Roman statues with a device called a pointing machine. This tool measured points on a sculpture relative to a fixed reference, allowing those points to be replicated on another sculpture. By repeating this for thousands of points, an identical copy could be made. The method worked well for sculptures of the same size, but Borglum needed to scale his model up, from 5 feet tall to 60 feet tall. So, he designed his own massive pointing machine. It was essentially a metal arm with a weighted pointer that rotated around a fixed axis. By placing the pointer on his model, he could record 3 measurements: the angle, the horizontal distance, and the vertical distance. By multiplying each measurement by 12, the exact same point could be plotted on the mountain. Atop Mount Rushmore, Borglum built a giant version of this pointing machine. With it, thousands of points were transferred to the cliff, showing workers exactly where to drill and how deep to go. Instead of carving entire sections at once, workers drilled clusters of holes in a honeycomb pattern, then hammered away the rock in between. After hours of drilling, steel workers would descend on harnesses to replace dull drill bits, allowing the carvers to keep working nonstop. It was grueling work, 8 hours a day, dangling over a 500-foot drop, all for just 50 cents an hour. But progress continued, and eventually George Washington's head was complete. With his team well trained, Borglum turned to the finer details. One of the hardest challenges was the eyes. Greek sculptures typically had smooth, flat eyes that looked lifeless. To give the presidents a natural shine, Borglum carved deep sockets, leaving a small square block of stone at the center of each pupil. This square caught the light, making the eyes appear reflective and alive. It was an incredibly risky process. Any mistake could have sent massive rock slabs crashing down, but the result was breathtaking. Finally, to smooth and whiten the surfaces, workers used a process called bumping, which pulverized the outer stone into a fine finish. The carving of Mount Rushmore lasted 14 years. The original plan was far more ambitious. Each president was supposed to be sculpted down to the waist, and Borglum even envisioned a hidden tomb decorated with elaborate carvings. But World War II shifted resources away from the project. Soon after, Borglum himself passed away. The monument was left unfinished. Yet despite this, Borglum and Robinson had succeeded. Their project had placed South Dakota firmly on the map, creating one of America's most iconic landmarks. If you enjoyed this video, make sure to hit the like button and subscribe for more stories like this. Thanks for watching, and I'll see you in the next one. There is something unusual about Mount Rushmore. Unlike most sculptures that look painstakingly crafted, Mount Rushmore almost seems like it naturally emerged from the mountain itself, as if it wasn't carved by human hands at all. The reality, however, is that Mount Rushmore is not only a work of art, but also an engineering masterpiece. Despite having no artistic background, an enormous team of gold miners managed to carve these giant faces into stone, using jackhammers, dynamite, and some clever engineering. We modeled the entire thing to show you how Borglum's team mapped his design onto the mountain, using technology inspired by the ancient Greeks, and how all of this was achieved without a single fatality. But to understand why Mount Rushmore exists in the first place, we need to go back in time. In the early 1920s, the state of South Dakota was still young, and it was struggling to make a name for itself. State historian Don Robinson noticed how tourists from across the country were flocking to a new sculpture in Georgia. This gave him an idea. He reached out to the sculptor Gutzon Borglum and asked if he'd be interested in creating a giant monument of America's Wild West heroes. Borglum liked the idea, but argued that national figures like presidents would attract far more attention, and so, in the summer of 1925, he traveled to South Dakota and discovered Mount Rushmore, a 500-foot-tall granite cliff face. Borglum instantly knew this would be the perfect blank canvas for his project. With the mountains secured, he began studying photographs of U.S. presidents and built a 1/12 scale model of what he envisioned. Now, he had to figure out how to make it real. At that time, Mount Rushmore had nothing. No roads, no electricity, not even a way for workers to climb the cliffs. So, in the summer of 1927, a road was built to bring people and supplies to the site. Soon after, an entire village grew at the mountain's base, with workshops, blacksmiths, and houses for workers. A huge staircase was built to reach the summit, and a cable car was installed to carry tools and materials up and down. At the top, a winch house allowed operators to raise and lower workers on small wooden seats to any point on the cliff face. With all this infrastructure in place, the team was finally ready to begin carving the first head George Washington. Using carefully placed dynamite, the crew blasted away massive chunks of rock, shaping a rough egg-shaped head. From there, workers switched to jackhammers for the finer details. But operating 30-kilogram jackhammers while dangling off a cliff was no small feat. The jackhammers were powered by compressed air. At the mountain's base, 3 massive air compressors, running on electricity from a local gold mine, pumped air through a 2,000-foot pipe up the staircase to the top. Here, as many as 16 jackhammers could run at once. To control the machines, workers developed unique techniques, sometimes chaining themselves to the rock, other times using their feet to guide the jackhammer. They became experts in the craft. But even with this skill, one big question remained. Without artistic experience, how would they know where to drill? On Stone Mountain in Georgia, Borglum had used a large projector to map out his design, but Mount Rushmore was much larger, and the three-dimensional faces made projection impossible. He needed a new solution.